All right, yeah, week 2 stuff. So we're just gonna jump right into it. I'm assuming everyone has Fusion now and they got it working and stuff. So we're just gonna jump straight into it. Yeah, constraints. So last week we talked a little bit about constraints, and we primarily used the dimensional constraint, right? So if you remember, we were setting like certain dimensions, being like, oh, this point is this amount far away from this point, or this these two lines are like this angle from each other, or like this diameter is this much. But there's many other ways that you can define certain features in your sketches, and typically we call these geometric constraints. So again, most of the time our goal is to have a fully defined sketch, so all the lines and curves are all black, and we can utilize these tools to get us there. So if you're familiar with like basic geometry, I'm sure some of these are pretty self-explanatory to you, like parallel and perpendicular. But then there might be some that you might be a little bit more unfamiliar with, like coincident and collinear. But all of these have a description. I won't read them all, but you guys have access to the slides, so you can kind of understand what they do. You'll be probably using like coincident, concentric, midpoint, parallel, and perpendicular pretty often. But you can see like there's a bunch of other tools like tangent and equal that are also pretty popular. It just kind of is all circumstantial, and you'll kind of get a feel for it as you do it. I will say though, there is a fixed constraint with like this lock symbol. I really encourage you to avoid using that as much as possible because it's just kind of bad practice. Basically what it does is you can like move something arbitrarily and then fix it in place, but it's not really accurate, right? Because you can move something arbitrarily and then you can make it not move, but then if you relate things to something that was arbitrarily defined, then it's not the most accurate, if that makes sense. So there's some like really like specific niche cases where you might want to use the fixed constraint, but typically that's something that I urge you to not use. But yeah, we're going to be doing a quick demo. I'm going to let you all go free and try all these constraints. So yeah, does anyone have any initial questions? What's up? Oh, okay. So if you haven't downloaded Fusion, there's an installer on the Discord. I believe it's under resources. If you go to the top, there's an installer, and then you can just run the installer and let it download. And you can also make an account while it's installing. I can try to help you, but unfortunately, I don't really have a TA right now. So yeah, it is just me today. But yeah, let's just jump right into it. We're going to be doing assignment 4 right now for geometric constraints. So if you go under the Discord, there's this geometric constraints file in the resources tab. Feel free to download it, and then we'll put it into Fusion real quick. Okay. So to do that, find wherever you want to put it. Just click upload. Select the file from your file explorer or your finder. And then you just click upload. And then once it uploads, you can just double click it. If you're having trouble finding this, it's all in the data panel. If you click up here, but I'm just going to hide the data panel now. Everyone good? Okay, sweet. So with this assignment, we've kind of given you like a canvas with some text on it, along with a sketch with some instructions. So basically what you're going to do is you're going to edit the sketch and match the geometric constraint to the instructions, right? So you don't want to make a new sketch. We're going to edit what's already there. So if you go in the timeline on the bottom, you can right click it and then click edit sketch. What's up? Where's this file? It's on the Discord under resources. It's like assignment 4. Yeah. So you just edit the sketch, again, not making a new one, and then it'll allow you to manipulate these different features. So a lot of these won't be black because they're just kind of placed arbitrarily. So don't worry about them not being fully constrained. But you know, we can go about doing this by adding some geometric constraints, right? So before last week, you may have taken like this instruction to make it perpendicular and then use the sketch dimension and clicking these 2 lines and setting it at 90, which works. But the better way to do it is by using a geometric constraint. So over here, you can see all these red icons. And if you click down on this constraints button, you can see there's more options for you. So you just want to use these. You can either select the constraint that you want and then click the 2 things that you want to be constrained, or you can click the 2 things that you want to be constrained and then click the constraint button. Kind of a personal preference. I like to click like the 2 things beforehand and then applying it, but you can do it the other way around if you so choose. So again, I just shift click the 2 things I want to be constrained, and then it'll allow me to choose one. I guess one nice thing is that if you select 2 things, it will like make certain constraints unavailable. So like, you know, these 2 lines can't be tangent to each other because there's no arc. So it'll like make this constraint like impossible to click. But you can see like I can add this perpendicular constraint, which is what I want, and then it just makes it perpendicular, just like that. Seems pretty reasonable, I hope. Yeah? Oh, okay. So I'm just going to be doing a couple examples, and I'm going to let you all go. I don't know, we can all try this for like 10 minutes, and I can walk around to see if anyone needs any help. So I'll just do this next one. It says make these 3 lines parallel. So I'm in the perpendicular constraint right now, so I'm going to change to parallel. And then I'm going to click these 2 lines, and then these 2 lines. You can see they kind of overlap, but if I move it, they're all parallel. And if I tried to move the other ones, it'll kind of move with it. So, yeah. Seems good enough? Sweet. Okay, so I'll let you all go. I'll just walk around the room. So if you need help, just raise your hand. All right, so a couple people were a little bit confused on some of them, so I'm just going to walk through a couple of the more difficult ones, because I guess some of these instructions are a little bit up for interpretation. So I'm just going to do this one here, and then the last one on the bottom right. So for this one, it says dimension circle number 3 to 2 inches in diameter, and then fix circles 1 and 2, and then make circle 3 tangent to both of them. So to start, I'm going to add a sketch dimension like we were using last week. So, oh, I don't want that. So I'm going to click this, and then I'm going to make this 2 inches in diameter. And then I'm going to fix circles 1 and 2. So again, I typically don't use this, but it's good to know how to use it. I'm going to use the lock, and then I'm going to click on these two circles. And you can see they turn kind of like this greenish yellow, and that's just to signify that it's fixed. So you can see now that like if I try to like drag it around anywhere, it just doesn't let me, because it's fixed. So again, like these are arbitrary, so that's why I think they're not really accurate, but that's how you use them. But the last part is to make circle 3 tangent to 1 and 2. So I'm going to use the tangent tool and then click on these two. You can see it snaps in place, and then I'll click those two, and then it snaps that in place as well. Does that make sense? Okay. And then for this last one, there's a couple ways that I've seen people tackle this. Technically, if you make all of them concentric, they're all on the same horizontal plane. But the way I like to do it is just kind of making them on like one actual like line. So the first one is like typically pretty easy. If I use this horizontal vertical constraint and I click the centers of these two circles, you'll see it snaps into place. But if I do the same thing for this one and this one, you can see that it snaps like vertically, right? And it's just because like Fusion will just make assumptions for you a lot of the times, and it'll make like the easiest like snap or like easiest constraint that it can make. So if you look at this, like this circle is closer to like the vertical axis on this circle than the horizontal. So then it'll automatically like choose the easiest one, right? So if you want it to do something that is like not the easy way, you kind of have to massage your drawing to make it easy for the computer to compute, right? So in this case, that just means like I'm gonna move this circle here, and you can see like if I draw like an imaginary line between these two centers, it's a lot closer to horizontal than vertical. So when I do the same constraint again, it'll snap horizontally. Does that make sense? I mean, technically, like if you made all of them like concentric, like this is technically right too. So yeah, this is like kind of arbitrary, but I prefer if you guys did it this way, but like it's fine. As long as you understand how these tools work, that's the purpose of this assignment. So yeah. Does anyone want me to run through a different one before we move on? Oh, like delete a constraint? Um, I forget. There's like some shortcut that allows you to like see some of the constraints. Uh, I kind of forgot it. But a lot of the times I just like delete something and I just redraw it. Because I just find that to be faster, especially when you have like a lot of constraints. Um, Sometimes one of the constraints will cause something to break. So I usually just start from a fresh canvas and then I'll delete like an arc or something and then redraw it. Yeah. Yes. So again, if you when you go to submit it, just like take a screenshot of everything. Um, again, please make sure you have your timeline included in your screenshots. It doesn't really matter for this assignment, but for the next one, it will matter. And so, yeah, please submit it so I actually know that you're doing it correctly. Yeah. When do we have to submit? Okay, yeah. So the homeworks are due before the next class. So you basically have a week to do the homework. If you like need an extension because you had an exam or something, just let me know. I'm pretty flexible about it. But you know, please don't like not do any of them for 5 weeks and then freak out at the end. That's just gonna suck. So yeah, if you can turn them in a timely manner, that would be preferred because that usually means you'll pass the class. Sweet. Okay, so with that out of the way, um, we're gonna move on to assignment 5. So you've kind of seen like how we use certain tools in Fusion to make our lives easier. And I like to say that like being lazy when you're CADing is a good thing. It's obviously like circumstantial, like you don't want to like go overboard with being lazy. But a lot of the times you can be lazy as in you can use Fusion to make your life easier um, because you can edit things easier later. That was very poorly worded, but you'll see what I mean in a bit. Basically, for stuff like this, we have this gear, right? And the shape of a gear tooth is typically identical on every single tooth, right? So you could like draw every single tooth like individually and like dimension it and all that stuff, but that would take forever. And then let's say for example somebody asks you to make the tooth bigger or smaller, then you have to like edit like 30 teeth, right? So that's typically not really ideal. So we can be lazy and we can have Fusion do a lot of the work for us, right? So how we're going to do it is we're going to make one tooth profile and then we're going to have Fusion copy it over and over again to create a gear, if that makes sense. So Fusion's powerful. It has a lot of features. I really encourage you to use it just because it'll make your life easier, especially if you need to edit something later. So let's just get into it. So creating a new design here, I'm going to start with a sketch like we normally do. So I'm just going to create a sketch here, select this plane, and then I'm going to just create a nice solid base. Just going to make a simple circle, drawing from the origin, and then selecting some diameter. Again, you don't have to copy the exact numbers that I'm doing as long as you're getting the hang of tools. So yeah. So this circle is fully constrained because I drew it from the origin. I like that. So now I'm going to just start drawing this tooth profile. So what I'm going to do, I'm just going to draw up. I'm going to go across, and then I'm going to go down. Typically, I like to draw it like a little bit weird, just so I can make sure that I apply the constraint properly later. So I'm going to make this vertical. And then I'm going to start setting angles for this. So this should be horizontal. And I made that horizontal too. Okay. I'm I'm going to add some dimensions. And we have like half a tooth profile here, right? Does that make sense? To add an angle, you use the sketch dimension tool, and then you select 2 lines, and then it'll allow you to make an angle. You have a question? Okay. So the last thing I'm going to do here, I don't really want this line to be a part of like the extrusion. So I'm going to make it a construction line. So a construction line is nice when you're designing something, because you can set like arbitrary points or like geometries that may not be in the final product, but are like important for like dimensions, right? So if you have like a big pattern of like holes or something, you can make like uh, like a hexagon or something, and then make those construction lines, and then draw circles off of that. I don't know, I can show a good example later, but for now I'm just going to make this line construction. So to do that, you just click construction over here, and you can see it becomes like a dashed line. You can also see how like it doesn't include um, like this profile as a closed body, because I added a construction line. So when I went to, if I go to extrude this right now, I won't be able to extrude this tooth, because Fusion won't count this construction line as like a closed off body. If I was to undo it, you can see how the center of this area becomes highlighted, but I don't want that right now. So I'm going to turn that off, and then I'm going to add a mirror. So again, this is half a tooth profile, and I'm going to use Fusion to mirror it and create a full tooth. So I select 2 objects. In this case, it's these 2 lines, and then kind of an axis at which I want to mirror it. So I select these 2 lines, I select mirror line, and then I click on that construction line that we made earlier. When I press OK, you can see how this is now a closed body and it's highlighted blue. So that's kind of what I was looking for. So now we have this tooth profile, right? And we can adjust it if we want. I'm just going to leave it as it is. But now I'm just going to add more teeth. Is everyone good up to this point? Okay, cool. So I'm just going to highlight all of these parts of the tooth, including this construction line right here. And then to create multiple copies, I'm going to go under Create and Circular Pattern right here. I've already selected the objects, so it's going to ask me for like a center of where it's going to pattern it. So I'm going to click this and then click on the center of the circle. And then it'll ask us how many we want, right? So I can ask to create like 7, or like increase it. And you can see in the preview, I can add more or like reduce the number, right? So I'm satisfied with this. I think 9 teeth is fine. I'm going to select OK. And now you can see how we have 1 tooth with multiple copies referencing that. So if I was to edit the tooth we made at the beginning, maybe set this to 50, you can see how all of them change together, right? So again, like I'm being lazy and just drawing 1, but in the end it's more powerful because I can edit all of them at the same time. So, yeah. So I'm satisfied with this. I'm going to finish it and extrude it. It'll ask you to select each individual tooth just because they're all closed bodies. I can specify a distance, maybe like 10 or something. And then I'm going to press OK. And then there we go. We have our basic gear. Um, so if you see in this gear here, there's a threaded hole. So there are like a couple ways you could go about making a hole. Um, the way that you might be like familiar with right now is by creating a sketch, making a circle, and then extruding it into a hole. And while that like technically is like a way to do it, when you use Fusion for more like uh, engineering applications, they want you to retain as much data as possible. So when you use something like the hole tool instead of the extrude function, you'll be gaining a little bit of data, and it'll help people who might be making your part later, right? So a lot of the times, you'll be sending a part to someone, and then they'll make it for you. Um, and when you can give them as much data as possible, that's ideal, right? So um, especially when it's like a CNC part, um, people will use like computers to program like a machine to make your part, and Fusion can use like the whole data to like select certain tools and stuff like that to create it. But if you have it as like an extrude, the uh, the software will think of it as like a pocket instead of a hole. So it might use a different tool, and it can be more expensive and like a little bit less ideal for the machinist. Um, so again, for this assignment, I asked you to use the hole tool, just because it's good practice. Like if I CAD something by myself, I may not do it, but like when you want to CAD something for other people to use, the hole tool is definitely more ideal. So again, I'm just going to use this hole tool, which is right next to the revolve, and then you select a point. So uh, what you could do if you're doing multiple holes is you could create a sketch and then add a bunch of points on the sketch and dimension them out. But because we're just putting it in the center here, I'm just going to be lazy and click on the center of it. But you can see it'll give you a preview, and you can also see over here all the options you have when you use the hole tool, right? So again, you can add something like a tapped hole, which is what we want in this case, because we want threads in it. You can specify a bunch of stuff here because there's a bunch of standards for hole sizes. Oops. So again, this is a lot of data that is valuable to a machinist or someone making your part. So it's good practice to keep it there for them to reference. So in this case, I'm just gonna choose some arbitrary size. Let's do like 38 millimeters. That looks good to me. Yeah, I'm gonna press OK. But you can also see, we're just doing one type of hole, but there's a bunch of different options depending on your application. Feel free to mess with it. Like you can add like a countersink or a counterbore. I'm just gonna leave it as simple. But the whole tool is really nice. Please use it. It'll be pretty helpful for you if you decide to make parts later. Yeah, you can see now we have these nice threads here. And yeah, that's basically this assignment. Does anyone have questions? Is it off center? So I just kind of like clicked on the center of the origin right here and it snaps into place. But again, if you have multiple holes, you can create a sketch and then you can click on those points and it should snap to that. Yeah. Everyone good? I feel like I'm speed running class today. So if I'm going too fast, just let me know. Cool. All right. Is everyone ready for the next one? Yeah? Okay. So this one's a little bit different compared to the gear that we just did. But utilizing different planes is a great way to add like special features to your designs. Obviously, there's more than one way of doing something. So if you take this like body of the hair dryer, for example, you could revolve it just like we did for the game piece last week. I just want to teach you this way just so you know like there's more than one way of doing it. And also like lofts are pretty cool. And this is just like a pretty simple example of what a loft can do. But yeah, again, this isn't the only way to make this, but we're going to do it this way just so you know how to do it. So yeah, I'm going to create a new design and I'm going to create, actually no, I'm not going to create a sketch. So I'm going to show the origin. So typically when we start our designs, we have these three planes that we reference off of from the origin. But there are cases where we want to make new ones, right? Sometimes you want to reference something that's in the middle of something you've already made, or you just want to make a plane at a really weird angle so you can create like a special feature, right? So today we're just going to be making a bunch of planes that are kind of parallel to each other. But just know that planes can be a lot more complex if you want them to be. So basically, I'm just going to be using this top plane here, and then I'm going to be creating a bunch of other planes that are offset from it. And then we're going to create a loft, which will kind of smoothly transition a bunch of sketches into one nice body. So to do that, there's this construct icon up here. I'm going to start with an offset plane, and then I'll also make a mid plane just so you kind of understand what they do. I'm going to start with this offset plane. I'm going to select a plane that I want it to be offset from. In this case, it's going to be the top plane, which is this one. And then I'm going to specify some distance, right? So I set that to 30. You can kind of see how this plane is like offset from the top plane, which is good. But we're going to make a couple more. So construct offset plane. This time I'm going to click on the plane that we just created, and then I'll offset it some more. Maybe like, let's do 100 this time. So now we have 2 additional planes. We'll make 1 more. In this case, I'm just going to use a midplane. You don't have to do a midplane, but I'm just showing you what they do. For a midplane, you select 2 different planes or faces, and then it'll create another plane in the middle. So I made a really large offset on the second one, so I'm going to click that in the original one, and you can see it's creating a plane that's smack dab in the middle. So this looks good to me. You can adjust it a little bit if you like. I'm going to change this to like 90 or something. Actually, no, I'm going to make it longer. Okay. Is anyone having trouble with the planes? Sweet. Okay. So now that we have our planes, we're going to create an individual sketch for each plane so we can create a loft, right? So if you look at this presentation, you can see how there's 4 circles. They're not on the same sketch. We're making 4 separate sketches on 4 different planes, and then we're going to use it to create a loft, right? So I'm just going to start by creating a sketch on this bottom face right here. I'm going to create a circle on the origin. I'm going to dimension it, maybe like 80 or something. And then I'm just going to leave that. I'm going to finish it, and then I'm going to move on. I'm going to create another sketch. And then this time, I'm not selecting the same plane. I'm selecting one of the planes that we created. So for this one, I'm going to make it a little bit larger. I'm centering them all on the origin, so they're all concentric with each other. Do like 120. And then I'm going to do it 2 more times with the last 2 planes. So another one here. Adding a constraint. And then 1 more here. Does this make sense? Everyone's good? Okay. Also, if you're ever like curious about like where your planes are, you can hide and show them with like these little eyeballs up here in the top left under construction. And then you can also do the same and like hide and show the origin. I'm just gonna leave them like hidden now just because I've created these sketches already. But yeah, that's there if you need it. So now that we have all our sketches, you can kind of see, if we look at it, this kind of potential profile we could have, right? So what the loft is going to do is it's going to take all these sketches and make smooth transitions from one sketch to another. So we need to make sure that we select the sketches in the correct order, or else it's going to like loft to like from here to there, and then it's going to go backwards to here, and then back up to there, and then we're going to have like some weird like inside out body. So we don't really want that. So I'm going to create a loft, and I'm going to make sure to select them in the right order. So go under create and loft right here. And then I'm just going to click on these profiles. One circle there, one circle there. And then there we go. So you can see how it's using these sketches as kind of guides for the loft, and it'll create a nice smooth transition. I think that looks good, so I'm going to press OK, and boom, we have a nice lofted body. Does that make sense? Sweet. Okay, so now that we have this vase looking body, we're just going to hollow it out real quick. So a nice useful tool for hollowing something out is the shell tool. So basically what it does is you can select a face, and then it'll hollow out everything inside to a specified dimension. So I'm going to click on this top face here, and then it's going to ask for a thickness. So it's basically just asking you how thick do you want this wall to be. It'll kind of look like a vase when we finish. So if I set it to like 3, you can see that, you know, this thickness is 3 millimeters. If I was to increase it, that wall would increase and get bigger. I think 3 looks okay, so I'm just going to leave it there. And I'm going to set it to that there. So now you should just have like this vase looking part. Does that make sense? Sweet. Okay. So I'm just telling you now, I'm purposely doing something in like an incorrect order, just so you can see how you can move things later and how it affects your model. So we're going to be moving this shell later, but just like keep that in mind. You'll see in a little bit. The last thing we're going to do to the body of the hairdryer is add a fillet. So I'm going to add a fillet on this outer edge right here. Please don't select the inner edge. And this is important just because we're going to be moving the shell later. And if you select the inner edge, it won't allow you to move it, just because it'll make this fillet dependent on the shell. I'll do it wrong just so you can kind of see later. So for now, just do the outer edge. I'm going to do the outer and inner just so you can see how things might break. But I'll fix this in a little bit. So you should have this outer edge. It's nice and round so you won't cut yourself. And now we're going to focus on making kind of this handle here. So to do that, we're going to be making an extrusion off the side, and I'm just going to create another plane to do that. So I'm going to create an offset plane. I'm going to offset it from one of these planes off the origin, not the top plane, but one of these. And then I'll move it to be like slightly outside of this hairdryer body here. So 70 seems okay to me. Probably go a little bit less if I wanted to. Yeah, I'll just do like 65. Sweet. Okay, so I'm going to create a sketch on this newly made plane, and then I'm going to start drawing the body of, or the handle of this hairdryer. So I'm just going to kind of make it in this arbitrary place. I'm going to add some constraints like that, so it's snapped to be vertical. Going to add some quick dimensions. Boom, fully defined, looks good. I'm going to finish it, and then I'm going to extrude it. So in this case, you can see if I extrude it in this direction, there's this kind of gap in between the head of the hairdryer and this handle. So I'm going to extrude it this way just because I'm going to start that for the handle, but to combine it, instead of one side for the direction, I'm going to make it two sides. So if you set it to two sides, you can specify two different kinds of extrudes on both sides. So in this case, like the first one is just kind of arbitrary like number, so maybe like 200 or something. But for the second type, you can set it, instead of having it at a set distance, you can set it to be up to an object, right? So there's this to object option. It'll ask you to select the object, which in this case is kind of the head of the hairdryer, and then it'll make a nice extrusion that wraps around the hairdryer body, right? You can see if I was to make it like an arbitrary distance and do like 10, you can't really see that well, like 30 millimeters, you can see how like this piece is like extending into the hairdryer, which is not really what we want in this scenario. So that's why I set it to object, and then I select this face. So it makes a nice clean extrude up to the surface. I'm satisfied with that, so I'm just going to press OK. And there we go. You can see if you look inside, there's a nice smooth area. There's no protruding like extrusion from the handle, so that's good. Yeah. The last thing we're going to do to this handle is add a chamfer. So similar to a fillet, you'll select an edge for a chamfer, and then instead of rounding the corner, it'll kind of create like an angled cut. Typically, chamfers are usually 45 degrees. That's the default. But if you wanted to change that, that's possible. Again, to make one, you just go under Modify and then Chamfer, and then you just start selecting edges. So if you select this edge right here and you specify a distance, maybe like 2, you can see there's this nice angled chamfer. Maybe I'll make it bigger. Again, it's usually 45 degrees. Typically, you won't really need to change that. If you wanted to change it, you could change it to like to distance or distance and angle. But equal distance just will make it 45 degrees. Yeah. Sweet. Okay, so I'm happy with that. I'm going to press OK. And now we have this hairdryer body, right? So now that we've created it, let's say, for example, we wanted to also hollow out the inside of the handle to have like electronics or something inside of it. We could do that with the same shell that we created before. But if we reorder things, it can change the model, right? So the timeline acts, as a timeline. It's like a story of how you created your part. So depending on where you put certain features, it can actually change the way your model ends up, right? So because right now we shelled the hairdryer before we made the handle is solid, right? But if we were to create the shell after we created the handle, it would shell out both the head of the hair dryer, but also the handle as well, right? Um, but if you ever wanted to move something, in this case, I want to move this shell to be after this handle, you need to make sure that some of the features following it aren't dependent on the feature that you've created, right? So in this case, like I purposely did it improperly. Um, so you can see like I added a fillet on the outside as well as the inside, right? But if I was to create this shell after the fillet, that would be impossible, right? And the reason is because the fillet is dependent on the shell to exist because it's referencing this shell for the fillet to exist, if that makes sense, right? So what you typically could do is you'd be able to select your feature and drag it across the timeline. But you can see when I try to do that, it's not moving. And it's because this fillet is dependent on the shell. So I'm going to fix that by editing the fillet. I'm going to remove the original fillet, and then I'm only going to do the outer radius, or the outer diameter. So in this case, I'll do like 1 millimeter again. And when I do it, you can see this edge is nice and clean, and nothing is dependent on the shell anymore. So if I try to move the shell now, I guess I'll move it in a better position so you can kind of see. If I move the shell now, I'm going to drag it. You can see it's moving across the timeline. As soon as I let go, you can see how the inside of the handle is now hollow, right? So that kind of shows, again, we did the exact same features, right? The number of features didn't change, but the order in which we did it changed, and it changed the model, right? So that's just something to keep in mind. Um, you can move things around, and they might be advantageous to what you're trying to do. Does that make sense? That's kind of like a nitty-gritty topic, but yeah. I'm gonna do the last part of this assignment, and then I'll kind of go around the room again to see if anyone needs help on this. Um, so the last part of this assignment is kind of the little wire coming out of the hair dryer. So what we're gonna do is we're gonna create a sweep. So a sweep is kind of similar to a loft, where you're combining multiple sketches to create a special profile. But what a sweep does instead of a loft is you'll have one fixed profile and then a path at which it follows, right? So, if you look at a cable, like the diameter of the cable is kind of the same throughout its whole length. So we're going to set that diameter, and then we're going to create a path for the wire to be like extruded along, if that makes sense. So again, we're making two sketches. I'm going to start with the profile of the wire. So I'm going to create a sketch on the center of this circle right here. I'm just going to draw the circle out here just to kind of show you. I'm drawing this in like an arbitrary space, but then I can use a geometric constraint to set it to be concentric to that. So now it's nicely centered on the handle. And then I can just specify a diameter, do like, I don't know, 15. Yeah, that looks good. The wire is going to be about that big in this case. So after that, I'm going to create a path for this sketch to follow. So in this case, I'm selecting this plane right here. And the reason why I'm selecting it is because we drew this handle to be kind of centered along the origin. So when we draw on a plane perpendicular to it, it'll cut straight through the middle, and the line will be centered on this circle that we've created earlier. So I'm going to create another sketch, and then I'm going to just draw from this center here. If you ever want to reference something that might be like a feature or something from something else, you can use something called projecting a feature. So in this case, like I want to make sure that the line that I create is centered on this handle, right? So to do that, I'm going to reference part of the handle and then like create or build my sketch off of that. So I'm going to press P on my keyboard, and it'll allow me to project a geometry. In this case, like if I want to project this face or this edge right here, so if I select this circle, the circle will be a line on my sketch just because it's perpendicular to this face. So when I press OK, I'm going to hide the body real quick. You can see I have this purple line right here, right? So this purple line represents the projection, and then, it's purple just to differentiate itself. So what I'm going to do now is I'm going to create a line, and then I can set this to be on the midpoint of this. So there's the midpoint constraint. I'm going to select this end and then this line. And now I know this line is perfectly centered on the center of the hairdryer, right? I'm also going to make this perpendicular because I want the wire to come out straight. I'm going to set this projected line to be construction so it won't be referenced later. And then I'm just going to create a nice organic looking wire. This part doesn't really have to be like fully constrained. I'm just going to kind of make a spline. Oops. I'm going to make a spline with this tool right here, fit point spline. And I'm just going to select a couple points to just kind of create like a nice organic wire looking shape. I'm going to press that check mark when I'm done. And then just to ensure that the transition from the straight line and the spline is smooth, I'm going to be adding one more constraint and making these two tangent. So you can see there's a nice smooth transition. I'm happy with that. Again, don't worry if your spline isn't fully constrained. This is kind of organic and stuff, so I'm just going to leave it as it is. But now you can kind of see what's happening here, right? There's this circle representing the diameter of the wire, and it's just going to follow this path when we create our sweep. Everyone good up to this point? Okay, cool. So I'm going to go under create and sweep. It'll ask for a profile and a path. The profile is the circle that we made at the beginning, so I'm going to select that. And then I'm going to select the path at which it needs to follow, which is that kind of line and the curvy spline that we made. And there we go. We have a nice organic looking wire. And that's the hairdryer assignment. Does that make sense? All right, cool. Yeah, so that's basically it for today. For the homework, I'm gonna just warn you right now that this is probably one of the most difficult homework assignments for this course. This might take you a little while just because it's a lot of thinking in terms of what constraints you might want. But basically, we're asking you to recreate an extrusion profile. So if you've built 3D printers and stuff, I mean that's kind of what I do. A lot of the open source 3D printers are made out of 2020 extrusions, right? So basically, there are these aluminum profiles with these little cutouts in them, and it allows you to put things like hardware inside each slot, right? It's a very nice building block, especially for prototypes, just because you can kind of bolt things anywhere without having to drill holes and stuff. So it's a pretty common material that a lot of people like to use. So So we're just going to ask you to draw one up um, for your homework assignment. So this is kind of the extrusion profile and what it should look like in the end. Some of the dimensions are missing. So when you're trying to recreate this, please reference the slide after it. So this slide also kind of gives you a hint at like how I tackled this assignment. So again, similar to like the gear assignment we did earlier today, you can be lazy and then just draw up a portion of the profile because the rest of it is like symmetrical, right? So what I did here is I drew like half of one of the arms that sticks out, and then I mirrored it, and then I circular patterned the whole thing, right? So just keep that in mind. That's kind of my tip for you. The other tip is like utilize construction lines. So you can see here that like uh, these dashed lines on the outside and these diagonal lines here are construction lines, right? In the final like extrusion, it's not going to be like used to extrude the part, but it's a great like reference. Um, so like because it's a square, it'll make sure that every side is equal um, and that everything is like symmetric, um, just kind of like right. If that makes sense. So those are my hints to you, but make sure you utilize those construction lines and the geometric constraints. Also, just ask me if you have questions because this is one of the more tricky ones. But yeah. Yeah, so that's what I did. I mean, obviously, you don't have to do exactly what I did, but I recommend drawing something like that to just kind of give your sketch like a nice foundation. Um, yeah, so like I drew like a rectangle starting from the origin, and then like I set the lengths of the like lines to be equal to make it a square, and then I just drew like a line diagonally, and then I made all of those construction lines. Yeah, but yeah, that's basically it for today. If you have questions, feel free to stick around. Again, please fill out the attendance form if you want food on the last day. But yeah, I'll see you all next week.